Hello dear students, greetings from my side, Sat Sri Akal. How are you all? Fine. So today's our session is on 5 concept clearing problems related to the rotational motion. Okay guys, see, you're going to enjoy the each and every sum of this session. Stay updated and stay connected till end. Okay, so as being new, those students are new to this specific session, right? So the introduction is needed. Myself Indrajeet Singh, you can call me Indrajeet Bhaiya, right? I'm having 5+ years of teaching experience and given multiple airs into the general category, right? So Bachaji, this is what, the important thing is not like that. The important thing is passion towards the physics and explanation of it into the most simplified form, right? That is what needed into the physics educator, right? See, moving forward, this is a very awesome thing in front of you all. If you want to connect with the official team of an Unacademy, so you can move on to you can follow this Instagram handler. You can follow this by writing at the Unacademy JEE official. You can follow this. Okay, you will have the latest updates related to this channel, right? And whatever the sessions are going on, relate each and every point, like updates would be here. Okay, so one impressive thing has been introduced by the Unacademy. It is the most interesting thing, right? The access of all subjects, all videos of all subjects at just one click. You have to just enter the tinyurl.com/JEE mobile. If you want to see the physics video, it's okay. If you want to move on to the chemistry video, then it's okay. If you want to move on to the maths video, then also it's okay, right? Just press and play, access of all subject at just one click. Okay guys, see, Unacademy subscription, it is what about a most dedicated thing that Unacademy has introduced in front of you all. See, if I'm comparing this to an offline resources, and only once the scenario is created while introduction to the specific topic, but here we are having the lots of recorded sessions also. First of all, the educators of the country will have the live interaction with you all. And if you're going to mess it up and you are having the recorded sessions also, you can see those sessions infinite times. So that same scenario that once has been created, it is created infinite times. You are having the test series for your rectification, and even with the top educators of the country, you are having the doubt clearing sessions. Okay, so moving forward, see, these are the glimpse of the courses going on to this platform. The first one, that is an evolve course. Second, that is an emerge course, and the detail courses. It is not like whatever it is written, it is there. The quality education has been provided by the top educators of the country. Yes, they are sharing the knowledge. Yes, they are sharing their knowledge. Okay guys, see, this is a glimpse of the platform. Moving forward, okay, see, you can see in front, see, those who are new to this specific platform, I'm showing you the procedure how to join it. First of all, just enter the Unacademy learning app, install it, and then move on for plus, and then just select JEE and Bachaji, get subscribed for it. Those who want to subscribe, they can use this code ISLIVE. Indrajeet sir is live, you all are live, physics is live, to immediately get 10% off. To immediately Bachaji get 10% off. See, lots of options are available. You are having 1 year, 2 year, lots of things are available. Even for the aspirants of the JEE, those who are appearing for the second attempt, they are having also the another options for the second attempt and the advanced. Okay guys, so those who are already on the plus, even they can use this code for the renewals to get immediately 10% off. So guys, are you all ready? We are moving forward to the most concept clearing, the most important concept clearing sum of this chapter, the rotational motion. Hi everyone. See, first of all, let us see those who are live. Ashok is there, Vaibhav is there, Vibhu is there. Okay, Siddhak, Preet is there. Nice. How are you all? Hi. Okay, so guys, moving forward to the most important question of this chapter. See, you have seen the lots of questions of the moment of inertia. Even you have applied many times the parallel axis theorem and perpendicular axis theorem as per your requirements. But the important thing is that while applying the perpendicular axis theorem, our desired axis of rotation is perpendicular to the known axis of rotation, the axis of rotation about which the moment of inertia is known. first case. In second case, either there might be the possibility the desired axis of the rotation is a parallel to the axis of rotation about which the moment of inertia is known. But here we are having a very different case. This sum will clear the concept. How? Let us see. Moving forward to this question, as shown into the figure, calculate the moment of inertia of the square plate about the desired axis of rotation. See Bachaji, this is the desired axis of rotation about which we have to find the moment of inertia of this square plate. Can we consider the length of the square plate as L? It is rotating like this way. Entire plate is rotating like this way. Okay, so guys, let us solve this, right? So in this case there is a very different, very different situation. Let us see. Suppose this is an axis, this is a square plate, right, of length L, right, and this is its center of mass. So guys, first of all, let us draw the axis of rotation about which we are having the value of the moment of inertia. This is the axis of rotation about which we are having the value of moment of inertia, that is also ml square by 12. This is known, and this is our desired axis of rotation. Okay guys, this is our desired axis of rotation. See guys, neither it is a parallel, neither it is a perpendicular. So in that case, in this kind of the cases, if you are facing any kind of the sums, right, in this kind of cases, right, just to draw the perpendicular from one axis towards the another, from the desired axis to the known axis, just draw the perpendicular. See guys, I am drawing up the perpendicular. You can see I have drawn the perpendicular. This is making 90 and this is making 90. Okay guys, see now this much amount of the angle is given as 15 degree. Okay, see, let us consider this angle. So this is 15 plus 45, so this would be total 60 degree. If I'm talking about this side of the, so can I say it is half of the diagonal of this square, that is L by root 2. Now consider this triangle and find this distance. If the normal is drawn from the desired axis to the known axis, that is only the distance considered, right? That is only the amount of distance considered. So this much amount of the distance would be, can I say, sine of 60, that is equal to, can I consider this as x, that is equal to x whole divided by L by root 2. So I am getting x is equal to L root 3 by 2 root 2. So the distance between the desired axis of rotation, and the known axis of rotation is that. Now moving forward, see guys, this distance we got. Now just see, about this we are having the ml square. Now we are applying the parallel axis theorem. So the moment of inertia about desired axis of rotation, that is equal to about this axis, ml square by 12 plus this much amount of the x distance, right? So that would be m, what is the distance? L root 3 by 2 root 2 whole square. Resolving this, I am getting the moment of inertia about the desired axis of rotation as 11 by 24 ml square. 11 by 24 ml square. So this would be the answer. 11 by 24 ml square. So that would be the answer. So yes, I'm getting the A as an answer. So guys, this was a very different situation in which the two axes, the desired and the known, they were neither perpendicular, neither parallel. So in that case, just draw the perpendicular, the normal from the desired towards the center of mass of the system. So that will help a lot, right, in this kind of the questions. Okay guys, so moving forward to the next sum. See, if I'm talking about the previous sum, that had cleared the concept of moment of inertia bit, right? Hope so it has been polished. Now we will clear up the concept of angular momentum and its conservation. Angular momentum and its conservation. So guys, moving forward to the next question. See, a circular hoop. Hoop, it means it is a kind of a ring-like structure. Hoop, it means it is a kind of a ring-like structure of mass m and radius r, rest on the horizontal floor, frictionless surface. See now, it is hinged about the point O. It is hinged about the point O. Now another bullet of mass m with a velocity v, it is moving forward. Bullet of mass m with velocity v, it is moving forward. Now it is striking to the edge of this hoop and get embedded inside. So in this case, yes, the angular momentum of the system is conserved. See, whenever I'm talking about the linear momentum and the conservation of the linear momentum and conservation of angular momentum, then in front of us, the entire system should exist, right? Not an individual particle. Why? Because we are taking an individual particle, then velocity of the individual particle and angular velocity is also going to change. But for entire system, the momentum is conserved, right? For entire system, momentum is conserved. So guys, let us see the solution for this. Suppose this is a hoop that is embedded about the hinged about the point O, and this is a bullet of mass m. The hoop is of the also same mass. It is coming with the velocity v. Now suppose about point O, the momentum is conserved, right? See, basically momentum are of the two types, the translational angular momentum and rotational angular momentum. Here, if it is moving forward and about point O, momentum is conserved, it means that it is having the what? Translational angular momentum. So here delta L would be equivalent to 0. So L initial, that is equal to L final. L initial, that is equal to L final. So moving forward, L initial m v about point O, this is the distance, perpendicular distance r. Now this was the initial condition. After that, what happens? It get embedded inside and it will give some kind of the angular velocity to the hoop also, and the same amount of the velocity that bullet will also gain it. So in this case, the moment of inertia of the bullet about this point would be mr square. For hoop, it is mr square. And they both are having the common angular velocity omega. They both are having the common angular velocity omega. So guys, in this case, moving forward, right, see, replacing the m is gonna cut. My answer would be v by 2r, that is equal to omega. So after the bullet gets embedded into the disk, the new angular velocity of this system, both bullet and the hoop, is v by 2r, by angular momentum conservation, of angular momentum. Okay guys, you got it? Yes or no? You got it or not? So moving forward, so this is my answer. Okay, so hope so this has been see, the two types of angular momentum are there. The first of one, the angular momentum that is decided for the translational motion, and second for the rotational motion. Okay guys, so moving forward, and the resultant, if the system is performing both translational and rotational both, then resultant is of L of translational plus L of rotational. Okay guys, so moving forward to the next sum. Very nice sum coming in front. Okay, let us see. A light inextensible string passes over this. See guys, this is a system, right? Okay, this is a system kind of a thing is given, and this is the solid cylinder. It is given, bachaji, this is the solid cylinder, right? See, M2, can you say M2 is given as the 8 kg mass, and this is given as the 2 kg mass, right? So for very short amount of the time, this 2 kg will definitely displaced by the height h, right? And it will force this cylinder to roll on the surface. It will force the cylinder to roll on that surface. So first of all, the most important note is that whenever we are having this kind of this situation, then this object always moves, it always rotates about Eicher point, that is instantaneous center of rotation, or you also you can say it as point of contact, right? It will be like this way, okay guys, it will be like this way. So guys, let us draw the FBD first, okay, and then we will resolve it, because we want to find the acceleration of the block. Okay guys, so let us draw the FBD first. This is a solid cylinder, and here tension is acting. Okay, and this is our Riker point, instantaneous center of rotation, or in another sense you can also say it as a point of contact. You can also say it as a point of contact. Okay, see, this is having the mass 8 kg. This is having the mass 8 kg. Now moving forward. See here, another mass 2 kg is there. The tension is acting into the upward direction, the mass is acting into the downward direction, and acceleration would be definitely into the downward direction. So according to the equilibrium of the forces, according to equilibrium of forces, the net acceleration is into the downward direction, and it is always into the direction of the higher magnitude force. So 2 into A, this is a net force, higher magnitude is of 2g, and the less one, that is a t. Can I consider this as equation number 1? Can I consider this as equation number 1? This equation has been obtained by means of the what? The conditions of the translational equilibriums. Conditions of the translational equilibrium. All horizontal forces are balanced, all vertical forces are balanced, right? If they are not balanced, then either they are having the horizontal acceleration or they are having the vertical acceleration. Now moving forward to the another point. See, I am taking the reference point as this. Right? About this, I have to apply the conditions of net torque, that is equal to I of P alpha. Right? See, only tension is there that is producing the torque. Only tension is the force that is producing the torque. So this distance would be 2r. So can I say T dot 2r, that is equal to, see, solid cylinder is having the, see, this kind of the situation is there. Suppose this is a cylinder, right? Then about this point, we are having the moment of inertia as mr square by 2. Now we have to shift for r. We have to shift that moment of inertia by r distance. So I am getting what? 3 by 2 mr square alpha. 3 by 2 mr square alpha. See, this r is going to cancel, and t would be 3 by 4 mr alpha. See, now the rotation happens about this point. The rotation happens about this Riker point, or you can say point of contact. So here for this we are having A is equal to not R alpha but 2R alpha. So alpha would be A by 2R. Replacing here, I am getting T is equal to 3 by 8 MA. I am getting 3 by 8 MA. So can I consider this as equation number 2? Replacing 2 in 1. Replacing 2 in 1. I am getting acceleration, that is equal to 2g by 5, and that is equal to 4 meter per second square. 4 meter per second square. Okay guys, so this was a very nice question, right? So everything we have to move on with respect to the instantaneous center of rotation and this kind of the cases. And this was a kind of the integer type question, and we got the answer as 4 meter per second square. We got the answer as 4 meter per second square, right Bacha ji? Okay, so this was the answer. Now moving forward, another question comes in front. This is a very nice question, right? So that will clear the concept of the conservation of energy. See guys, I am giving you the most important note. Whenever you have to find the angular velocity of the system, either move on to the conservation of energy or find a way to the conservation of angular momentum. If you have to find the alpha of any rigid body, right, then you should have direct approach toward the equation of the torque. Okay, again I am giving you the most important note. If you want to find the omega for the rigid body, specific, any process, any physical activity is going on, right? If you want to find the omega, then directly have an approach towards the conservation of energy or conservation of angular momentum. But if you have to move on, or if at any case, if you want to find the alpha, then you are directly approach, you should have the approach towards the equations of the torque and the conditions of the rotational equilibrium. See guys, initially the rod of the uniform mass density and a length L is held vertically and released. See, initially the rod is like this. Here is the center of mass of the rod. It is having the uniform, it is having the mass M and length L. Okay, now suppose it is released, right? Suppose it is released, right? So in this case we have to calculate the angular velocity of the particle. Angular velocity of the particle when theta, let us take an example, theta would be the 60 degree, right? So let us have this question. We will find the omega. See, we have to find the omega, na? then our approach should be directly towards the either conservation of angular momentum or conservation of energy. But here we do not have any kind of the collision between the two particles. The two particles are not striking something. It's not that kind of activity is going on. So in that case, I would recommend you all to move on for the conservation of energy. Conservation of energy, right? Conservation of energy. So guys, moving forward, see, initially rod was like this way. Center of mass was the, see, I am considering this as the reference point, right? There is no friction. It means that first of all, let me write this thing. Mechanical energy of the system is conserved. Mechanical energy of the system is conserved, right? So in that case, okay, we have to use this equation: K initial, U initial, K final, U final. K initial, U initial, K final, U final. So in this case, guys, see, initially, if I'm talking about the reference point, then here at the reference point, the gravitational potential energy is 0. At the reference point, the gravitational potential energy is 0. See, whenever we are talking about the potential energy of the rigid body, then distance between the center of mass and the reference point is taken. The distance between the center of mass and the reference point is taken. Initially, it is at rest. So kinetic energy is 0. Plus potential energy, can I say, mgl by 2. Now, suppose it is making this kind of the situation. So this center of mass has traveled this much amount of the distance. Now, this much amount of the distance. So this would be L by 2. This would be theta. So this height would be L by 2 cos theta. L by 2 cos theta. Now theta is 60. So can I consider it as L by 4? So final at this point, it is having the angular velocity omega. So it means it is having the rotational kinetic energy half I omega square. See, it is not having any kind of translational kinetic energy, right? It is having the rotational kinetic energy half I omega square plus this potential energy is calculated as mgl by 4. So here mg L by 2 minus L by 4, it is L by 4, that is half ml square by 3 omega square. Ml square by 3 omega. See, m is gonna cancel, L is gonna cancel, right? And this 2 is gonna cancel. So I'm getting omega is equal to under root of 3g by 2L. This is my answer as theta is equal to 60 degree. Omega is equal to under root of 3g by 2L. Okay guys, under root of 3g by 2L. So guys, this is my answer. Okay, this was a very nice question. Okay, so as I said before, just have one thing in mind. Just have one thing in mind. What it should be, if you want to move on, if you want to find the omega, then directly move on to the conservation of energy or angular momentum. You should have approach for this kind of the sums, right? And if you want to find the alpha, some calculations are related to the alpha or something like that, or force, something like that, then we have to move on to the equation of torque. See, we have seen the equation, like we have seen that application, now how to apply this conservation of energy in this kind of the sums, right, to find the omega. Now we will see, right, another approach by using the equation of the torque, how to find the alpha, or by using the alpha, how we can, or in another sense, in summarize from how we can apply the equations of the torque, right, in this kind of the cases. See, now another question. A slender uniform rod of mass m. See, you can see, bacha ji, mass is m and length is L, is pivoted at the one end, so it can rotate into the vertical plane. So this kind of the situation is that it can rotate into the vertical plane. It can rotate into the vertical plane. It can rotate into the vertical plane. So guys, see, very so there is a very negligible friction at this pivoted point. Okay, it is given. Koi problem nahi hai. Okay, no worries. Okay, see, we have to find the angular acceleration of the rod when it makes angle theta with respect to the vertical, right? Okay, see, initially, so see, a slender uniform rod is pivoted at one end so that it can rotate into the vertical plane. There is a negligible friction. See, suppose the initial condition is like this, when immediately suppose it is released, then what would be the angular acceleration of the rod at this point? It is suppose just it is released, then what would be the angular acceleration of the rod at that point, right? See, let us see. Okay, first of all, we will draw the FBD first. So this kind of the situation is there. Suppose it is making theta with respect to, see, as I said before, we have to find the angular acceleration, na? Then we should have an approach towards the equation of the torque. Here there is only one force mg. See, basically we are having the two forces, right? Here we are having the two forces. See, I am denoting the normal also. See, here's the y component of the normal and here it is the x component of the normal, right? But we have to calculate the torque about this reference point. We have to calculate the torque about this reference point. So in this case, we are having only one force that will produce the torque, and that also into the clockwise direction. So torque, that is according to the equation of torque, we are having torque is equal to tau is equal to I alpha. See, mg, what would be the perpendicular distance? This is L by 2. This is L by 2. So can I say this is, if this is theta, then it is L by 2 sine theta. So can I say this mg will produce the torque? Perpendicular distance to the mg is L by 2 sine theta. Moment of inertia, that is equal to ml square by 3 alpha. ml square by 3 alpha. So in this case, m is gonna cancel. Alpha would be 3g by 2l sine theta. 3g by 2l sine theta. Guys, this is my answer. This is my answer. Okay guys, this is my answer. So basically we moved on to some of the concept clearing sums related to the torque, okay, conservation of angular momentum, to the moment of inertia, to the most important topics of the rotational motion. First, we moved on with the moment of inertia. We saw a one sum in which the very nice concept was there. Second, we moved on to the some of the important concepts related to the torque, conservation of angular momentum, how the equations of the torque, the equations, the conditions of the rotational equilibrium, the conditions of the translational equilibrium has been applied to that pulley block system kind of the situations, pulley block kind of situation. And finally we saw the another last two sums. One, we have to find the omega. If we have to find the omega, then we should have approach towards the angular momentum, and or you can say if two objects are colliding, then we should have an approach towards the conservation of angular momentum or conservation of energy, right? But if you want to find the alpha, then we should have the approach towards the conditions or the equations or the formulations of the torque. Okay guys, so hope so by attending this 5 sums in this session, right, some of the concepts related to this rotational motion, the most important topics of the rotational motions has been cleared. So guys, we are moving towards an end. So guys, those who want to subscribe for plus, they can use this code is live. Indrajeet sir is live, you all are live, Bachaji physics is live, right, to get immediately 10% of off. Bachaji, lots of options are available here. You can move on to the 1-year course, 2-year course, 1-year course, 2-year course, and those who are appearing for the second attempt and JEE advanced, even lots of options are available. See Bachaji, I want to tell you one thing. If you are coming up on the you are subscribing or not, that is a secondary thing, but you should be updated to the environment. You should have some updations related to the whatever the things are going on into some surrounding. Okay, just visit the platforms. Okay, have a glimpse of some courses by the educators of the country, what they are actually sharing. Are they beneficial for you? Just have the glimpse of those courses on the platform. At least just visit once, right? So you will get a complete idea what actually is going on and what would be the benefits from that specific platform to you related to the upcoming attempt of the JEE and the JEE advanced. Okay guys, so from my side, see, subscribe to this channel. Press the bell icon to get the regular notifications about the sessions going on to the specific channel, and have the maximum shares and likes with this hashtag JEE daily. JEE live daily. Okay guys, so see, these are the lots of our channels. The first, this is the NIT, the JEE, the foundation, and this is on which you are having the regular updates of this specific session. It's all about the let's crack it. It's not let's crack it. We will crack the second attempt. We will crack the second attempt. So guys, again, those who are already on plus, they can use this code is live to get the 10% off for the renewals, and you hope so you might be having the lots of credits in your specific account. Okay guys, so it is near to the end. Again, Indrajeet sir will come with a new maps Mind maps, hope you have seen. Okay guys, I want to share you one thing. See, the thing is that if you will move on to the repeated sessions now, then it will help you a lot. See, notes are available and the link is also there into the description. It is not a big deal, you will move on to that, but this amount of the time that you will consume or you will acquire while moving towards the notes, the same amount of the time you will have, or you can attend the another sessions, right? So sometimes it is there na, if we are like hearing some things from the nearby surrounding, then it will create a more impact than we are reading up the things. Okay guys, so this is Indrajeet Singh signing off from the desk. Sat Sri Akal. Again sir will come with the new different concepts and a very new exciting things for you. So Bacha ji, bye bye, Sat Sri Akal.